Hello and welcome back to my GCSE Science. In this organic chemistry video we're going to be talking about addition polymerisation, which is a special type of addition reaction that involves joining lots of alkene molecules together to make a long chain called a polymer. Let's first look at a simplified version of how this works. The alkene molecules are called monomers. They're the building blocks for polymers. And during addition polymerisation, these small alkene molecules are added together in a long linked chain, normally of hundreds or thousands of molecules joined together, which is called a polymer. In earlier videos on organic chemistry, we've mentioned that this is one of the most common uses for alkenes. You'll need to remember that the monomer alkenes come from cracking the products of fractional distillation. And when the monomers are turned into polymers, we tend to call them plastics, which of course you'll know are very useful in everyday life, to make plastic bags, water bottles, sports shoes, electronics, furniture like tables and chairs, food containers, cosmetic products, all sorts of things. Therefore, alkenes as molecules and polymerisation as a process is really important for our everyday lives. Let's look at how addition polymerisation works. As we said, the monomers are always alkenes, so they'll always have a double bond. This is a simple illustration to show what happens to the bonds when monomers turn into polymers. You may remember from the topic on bonding that these bonds represented by sticks are covalent bonds, which consist of a shared pair of electrons between two atoms. The double bond then is made up of two shared pairs of electrons. So during polymerisation, one of those bonds breaks, leaving each carbon with a spare electron ready to bond with something else. Once the bonds have broken, we draw the monomers like this, showing the bonds sticking out of brackets, which represents that those bonds link up to something else outside of brackets. Now let's look at an example of how ethene, the smallest alkene, reacts in addition polymerisation to make polyethene. As we said before, the double bonds break, leaving each carbon on either side of the double bond with a free electron that's ready to bond with something else. So when we have hundreds of these molecules doing the same thing, they all link up with each other, joining up the spare electrons on the ends to make new covalent bonds. In the exam, you might see this written out in detail, showing several monomers on the left-hand side and several repeating units on the right-hand side. But it's often simplified or abbreviated to this example at the bottom, where N represents any number of polymers, normally a large number in the hundreds or thousands. And in the brackets on the left-hand side, we have the monomer, which the polymer is made from. On the right-hand side, we show what's called the repeating unit, which is the monomer that's had its double bond broken, with its spare electrons shown either side as sticks poking out of the brackets. On the right-hand side, the N comes after the brackets below the line, again to show how many repeating units exist in that polymer molecule. Now we can go back and draw this as an equation using just molecular formulae at the top here. Again, if we want to show polymerisation, we need to show N number of the monomers, which is ethene, shown in brackets, turning into polyethene, which is C2H4 in brackets, with a small n afterwards. In the exam, you'd normally get marks for drawing the monomer or repeat unit correctly, and also for drawing the brackets and ends correctly, so make sure you practice how to do that. Here's an example for you to try. Have a go at it first, following the same pattern as we just did with polyethene, and then come back to check your answer. With polypropene and any longer molecule, the first thing to be careful of is to draw the monomer unit correctly. Of course, so far we've normally seen these types of molecules drawn in a single straight chain, but when looking at addition polymerisation, it's really handy to get into the habit of drawing all molecules, no matter how long they are, as monomers with a similar shape and structure as we had with ethene a minute ago. This is so that the carbon-carbon double bond is kept central and you're less likely to make a mistake when the polymer is formed. So then, just as before, the double bond breaks into a single bond, leaving electrons either side available to make new bonds. The repeating units must match the monomers to make our long polymer chain. As we said before, this can also be simplified by just drawing one of each monomer unit and one of each repeating unit. And hopefully this is what you'll have written down. One more example to try: polybutene. In this case, I've written the molecular formulae first, And when drawing the displayed formulae, again it's a good idea to draw it in the same pattern as we had with ethene earlier, so that the double bond is central, which limits mistakes. Then that double bond breaks and links up with the neighbouring molecules, and here is a simplified version showing N monomers on the left and the repeat units on the right. You may remember that we mentioned in the previous video that there are actually several possible ways of correctly drawing butene. Many organic molecules, especially longer ones, can exist as what are called isomers. Now you don't need to know about this for GCSE, but it is worth knowing that there are several correct ways of drawing butene. Here's a brief example of a few of the different ways, just to give you the idea. So here we have the one that I drew, with CH3 groups on either side of the double bond. So to simplify it, I just drew it as CH3 rather than writing out the C with all the bonds. This helps to simplify the drawing of the molecule and keep the double bond central. Here's another form of butene. You can see it's still C4H8 with 4 carbons in a row, but the double bond is located in a different place. So now we've got a C2H5 group here on the right hand side, and to keep the double bond central, we can just write it as C2H5 and draw the rest of the molecule with the same pattern as we had with ethene. Here's another option, with the C2H5 on the left hand side instead. Strictly this is actually the same molecule as before, but if you're comparing your answer to another one, then it will look different. So here we've got the C2H5 on the left hand side, and so we show it on the left hand side in the monomer and the repeat units as well. And that's it for this video on addition polymerisation. Here are your keywords to learn, and I hope to see you again soon on the next video by My GCSE Science.